we're going to differentiate that. So we have our logs, and the rule for logs on your formula sheet and everything is just 1/overs. So f dash of x is equal to 1 over whatever's in there, so it's x over 2, multiplied by the derivative of x over 2. Now, here we go. I'm going to do this a little bit separate as well, because if you have x over 2, I think it's easier to think of that as being 1/2 times x. So if you have to find the derivative of that, so if you, I should use a different letter. If your function g of x was equal to 1/2 times x, just writing it that way instead of x over 2, then the derivative of that is 1/2 times, well, the derivative of x by itself is just 1, because that's power 1, you get 1x to the power 0, which is just 1/2, because that lot equals 1. So when you have that, the derivative of x over 2 is just 1/2, so we get the 1/2 here. Okay, it's the same method, 1 over that times the derivative of the inside part. Now watch out what this gives us. We've got 3 layers of fractions here, and in 3 layers of fractions we change that. Instead of dividing by the x over 2, we multiply, so we get 1 on the top, multiplied by 2 over x, all times the half on the end, which gives us 2 divides into 2 once, 1 over x. Isn't that interesting? You get that whatever's next to the x each time. You'll find that in general, if your function is log to the base e of a times x. Now remember, if it looks like a fraction, you can write it like that. Like that if you prefer. But in general, if your function is any number times x, that is equal to 1 over x. And the a by itself disappears, and that's because, that's the derivative of that, sorry. And that's because f dash of x, so I'm going from there to there now, is equal to 1 over the ax multiplied by the derivative of the inside part. The derivative of ax is a, so they always cancel out, and you just get 1 over x each time, which is kind of amusing, I think. Anyway, that's how you do that one. Okay, I'll stop the recording.